now going to review the systems of equations practice questions. So the very first question, what is the solution to this system? So here we have a graph of two linear equations, or a system of linear equations. And whenever we have a graph, the solution of the system is wherever the two lines intersect. So in this case, they do intersect in this one point. Sometimes they may never intersect if they're parallel, in which case there is no solution. Sometimes they might lie over on top of each other, and there are infinite solutions. But here we clearly only have one. So if we identify our coordinates, we can identify our answer. So I'm going to just write the coordinates for this. So it looks like we go over 2, so we have x equals 2. We go down 2, so we have y equals -2. So our solution is this coordinate, 2, -2. So that's what we would write in that little answer space. So let's move on to the next one. It says, which graph shows a system of equations? And I know some of you have used graph tools, so you can, I know Desmos will graph in standard form. But other than that, you can convert each to a form that you're comfortable with. So if you're more comfortable with slope-intercept form, you can solve this equation for y and create a graph, or you can graph directly from standard form. Right now, I just want to make sure you understand how to solve from standard form, so I am going to remind you of that. But let's deal with the first equation. One thing I noticed is that it's a negative sign right here, so we're going to have definitely a negative slope. So we're going to need one line that goes, remember our slope is change in y over change in x, right? So m is equal to delta y over delta x. So here I have a negative. You can put the negative with either number, but I tend to just put it with delta y. Why not? But you could put it with delta x. If it's -3 on top, that means we go down 3 and to the right 2. And then we also see our initial value. So at the y-axis, right? Or when x is equal to 0, we're going to start at 1. So I'm going to just go through and see, okay, which of these graphs start at 1 on a y-axis and it goes down 3 and over 2. So this goes down 3 and over 2. So it could be this one. This starts at 1 and it goes down 3 and over 2. So it could be B. This one, it starts at y-axis at 1, but this is going up. This is just the wrong slope, so it cannot be this one. So I can eliminate that answer. And here, okay, we start at 1 and we go down 3 and over 2. Okay, it could be any of those. And we can see, so this is definitely line number 1. And now we need to figure out, okay, which one satisfies line number 2. So this is in standard form. And the cool thing about standard form is it gives you your x and your y intercepts. My x-intercept, so that's where it intersects the x-axis. So x-intercept, that's horrible writing. I apologize. It intersects the x-axis, so I know my y is going to be 0 everywhere on the x-axis. But it's always your constant divided by what's in front of x. So 12 divided by 3 is 4. So I know it intersects the x-axis at 4. I think this is so cool because it's going to quickly get you some points to plot whenever it's in standard form. My y-intercept, so I'm going to put y-inter. It's this number divided by what's in front of y. So my y-intercept is where it intersects the y-axis. So my x is going to be 0. 12 divided by 2 is 6. And voila, I quickly got 2 points from my standard form. So I know my second line, I already know this bottom line. I already identified the first one. My second line is going to intersect the x-axis at 4 and the y-axis at 6. So I'm just going to go and see which one satisfies that. So I see this line right here. It's crossing my x-axis at 4, which is a little below my solid line, and it crosses the y-axis at 6. So it could be this one. So this one, it crosses the x-axis at 6. It's not that one, right? It needs to cross at 4. It's kind of doing the opposite of what we want. This one we already eliminated, and it's just double check to see if this one works out. So here it's intersecting the y-axis at -4 and -6. It's not this one. Everything's negative. So it looks like graph A right here satisfies both. Let's move on to our next question. I'm nice and zoomed in. I'm going to stay here. It says, which lines are parallel to 8 8x plus 4y equals 5. Select all that apply. So we know parallel means slope 1 equals slope 2 when we're comparing two lines. So that's for parallel. We don't have it here, but perpendicular, that's when slope 1 is equal to -1 over slope 2, right? They're negative reciprocals, and that's perpendicular. I'm going to just put this perpendicular symbol here. So they're asking out parallel, so we need to make sure our slopes are the same. The best way to do that is to get everything into slope-intercept form. It just makes it a lot easier to see. I also see one is in point slope form. So point slope form, the slope is whatever's in front of the parentheses, so we don't have to do anything. So here we see a slope of 2, a slope of -2, right? This is already in slope-intercept form. This is slope-intercept form, -2. But these two, we're going to have to switch. So to get into slope-intercept form, we just solve for y. We get y by itself. So I'm going to start here. Let's just rewrite 8x plus 4y is equal to 5. Oops, I left out my y. We want to get y by itself, so I'm going to start by eliminating the 8x. Let's move that over by doing an inverse operation. Right, we get 4y is equal to, let me see, -8x plus 5. And then we divide both sides by 4, right, to get that y by itself. So I get y is equal to -2x plus 5/4. So here my slope is -2, so that's what we're looking out for. So I know that's this. This is cool. This is cool. The slope is not -2 here. It's +2, so I'm going to just go ahead and get rid of that one. That's not right. And here I need to figure out what's the real slope here. Again, I'm going to have to solve that equation for y in order to figure that out. So let's do that. So it's going to be 8y is equal to -16x plus 7, right? So let's subtract the 16x from both sides. I'm going to divide both sides by y. So y is equal to -2x plus 7/8. My slope here is a -2. So that's also what I want. So it looks like all three of these have a slope of -2, only the last one did not. So let's take a look at our next problem. Allie strings together X red beads at 75 cents each and 3 purple beads at 30 cents each. She makes a bracelet that averages 60 cents per bead. Which equation can be used to model the situation? So let's just figure out. I'm hearing average, but let's just figure out how much for our necklace. I'm hearing each. So I know for every red bead, right, we're going to multiply by some variable x. They don't tell us how many. Here they tell us 3 purple beads. It's very clear. They give us a number. So here we're going to pay 3 times 30 cents, right? 0.30. Notice I'm using a dot instead of an x for times because I don't want to confuse it too. You can also use a parentheses too. That makes you here see it better. So that's how much we're going to pay whenever she strings something together. 75 cents times the number of red beads plus 3 times 0.30, because we know she uses exactly 3 beads. She says she makes a bracelet that averages 60 cents per bead. So I have to think about how I calculate an average. Whenever you calculate an average, you get the total and you divide by the total number of items you added. So we know we're going to have 3 purple beads, X number of red beads. We don't know what that number is. So altogether, we're going to have X plus 3 beads. But this is how much it costs, right? This is our total cost. So our average is we have to take that total cost. I'm not going to rewrite it. And we need to divide it by the total number of items. So the total number of beads would be X plus 3. And they said that that average, that's how you find the average, is equal to 60.6. So I'm going to go through and see which of these is close as possible to what I have. So this one, we're not dividing, right? We're not finding an average. We're not dividing by the total number, so it's not that one. And plus, we're multiplying 0.3 by x. That's not right. We don't have the same number of red and purple beads. For this one, it looks promising. 0.75x plus 0.30x. Oh, wait. We're saying we have the same number of red and purple beads. We know purple beads is equal to 3, so it's not that one. Let's see what else we have. 0.75x plus 0.3 times 3 divided by x plus 3. Okay, that's looking good. I like that one. And here we're not dividing by our average. This is not bad on the top, but we didn't divide by the total number of beads. So it looks like C is the correct answer.